Hello everyone and welcome to this video on getting started with linear regression in Python. In today's video, what we're going to be doing is we're just going to get started with Python and doing linear regression. This isn't going to be a video about what's going on behind everything and like all the math and stuff. If you're interested in the actual theory of linear regression, I recommend you check out my previous video, which I'll link somewhere up here. It'll be somewhere up here. And that video explains what's going on behind the linear regression model and as well, like all the math and all the basics of linear regression. Linear regression in Python is actually super simple. We're just going to be using a couple of Python libraries that have linear regression built into them. First, we're going to be using NumPy to create the data. And then as well, we're just going to be using a library called sklearn, which is a machine learning library that helps us just create the linear regression model so we're not having to do everything by hand. So if you haven't already, be sure to hit the like button as it really helps out the YouTube algorithm and as well will help more people see this that are interested in doing linear regression with Python. Okay, welcome to this tutorial on simple linear regression in Python. So what we're going to be doing is we're just going to be running a simple linear regression model and using packages such as NumPy, sklearn, and as well we'll visualize it using matplotlib. What we're going to do first is we need to import the libraries and the packages that we need. So we're just going to first of all import NumPy. So NumPy is a very popular package. We'll just say import NumPy as MP. And then the next one that we're going to be using is called sklearn. So this is a really good library for machine learning, and this is where we're going to be getting our linear regression model base from. So what we're going to do is we're going to say from sklearn.linear_model import linear regression, and the L and the R are capitalized on both of those. So what this does is it imports our linear regression model so that we can just use the model instead of having to go and try and hand calculate everything. And then the last one we're going to do is we're just going to say import matplotlib.pyplot as PLT. What these three packages are going to help us do, so NumPy is going to help us get the data set up how we want it to. And then the sklearn linear model is going to help us with getting the linear regression model and getting that all set up. And then matplotlib is just essentially going to help us visualize our model. So the first thing that we need to do is we just need to create an X and a Y variable. If you're using this on a real set of data, you're probably going to have to get the column names or something. But right now we're just going to create them ourselves, and we're just going to say X equals np.array. And then in parentheses, we're going to pass in a list. So I'm just going to pass in some random numbers. So I'll do 20, 40, 25, 30, and then 55, 18, and 7. And then one thing as well that we need to do is we need to reshape our X variable. So we're going to do this by just typing .reshape. And then we need to reshape it to have as many rows as we possibly want, and then only one column. So we do this by just doing -1, 1. So the reason we do this is because we're required to pass in an X variable as a two-dimensional array. So essentially this just means that we have one column and as many rows as are necessary. And then we'll create our Y variable. So Y, we're going to create another NumPy array. So we'll just say np.array. And then we'll pass in another list, just random numbers again, 5, 18, 22, 45, 60, 34, and 19. And we don't need to reshape this one for our sklearn. If we want to see what these are looking like, we can print both X and Y. And these ones right here are X variables. And then this is our Y array. So this is X right here, this column, this is Y right here. Now we can also look at the shape of both of these just so we can see, kind of what the shape is. So we do this by just saying print X shape and then Y dot shape. And we look at these and we see that our X shape is 7 rows by 1 column, and then our Y shape is just 7. And so now the next step in doing linear regression is we need to create our base model instance. We're just going to be using the default parameters as well right here. What we're going to do is we're going to create a variable called model, and then we're just going to set this equal to, we're going to call the linear regression model that we imported. So we'll say linear regression, and then we need to put parentheses and then do dot fit, and then pass in our X and our Y. So what this is doing is this is creating the linear regression model, and then we want to fit that, or essentially we want to create the best linear regression line with our X and Y data. So I'll run that, and then now we can actually see the results. Like, it was that quick. We can see what our R squared was. So we'll just create another variable called R squared, and we'll do model.score. And this is if we just pass in X, Y, and then we can print our R squared. And so now we can see that our R squared for this data is 0.50. Makes sense. I just threw in some random numbers. I mean, if we were looking at something, more in depth, we could have a higher or lower. As of right now, that's our R squared. And as well, we can get the intercept and the slope from the model we created. So we're just going to say intercept. We'll just create our intercept variable. And then this is going to be equal to model.intercept. And then you have to put an underscore at the end. And then we'll get our slope. And our slope is just equal to model.coef, our coefficient underscore right there. We can print those as well. Just say print intercept and then slope. So if we do that, our intercept here was 8.42, and then our slope is about 0.779, around there. As well, what we can do with this is we can see what the actual predicted values are for our regression equation. So we're just going to create another variable called y_predicted, and then we will create this variable, and we'll just set that equal to model.predict, and we'll pass in our x. So we're going to predict our x variables essentially, and we look at those, and these essentially what we're looking at is just the predicted variables with our linear regression model. And we're predicting for each x value. So at 10, our predicted value is 16.2. And then for 40, our predicted value is 39, and so on and so forth. And then we can actually go one step further, and we can create our regression equation. So we're going to say y_predicted equals intercept plus slope multiplied by x. So that's essentially how we're going to be able to plot the predicted. You don't have to create this as the same. You can just say y_new if you don't want to combine the two variables. I wasn't really going to look at y predicted again. And so then what we're going to do is we can just plot the actual equation, and we can just say fig, ax equals plt.subplots. This is where we need our, and then we'll set the fig size. This is where we need our matplotlib from. We'll just do 10 by 10. And then we can do a scatter plot for our actual x and y coordinates. So we'll just say plt.scatter x, y. And so this is what the data looks like just as a scatter right here. Just all of this. And then the next thing we can do is we can just do a plt.plot. And then we're just going to pass in our x for the x variable, and then our y_new as our y variable, and we pass that in, and boom, we now have our regression line right here. And we can kind of go back and we can verify that these are correct. So we said at 10, our predicted variable was about 16.2, which seems to be correct. And then at 30, I guess at 40, our predicted variable was 39. So yeah, looks good. And so that's really how we set up linear regression. It's super easy. I mean, this is an base machine learning type stuff, if that's what you're interested in. as well as just any sort of analysis. I think linear regression is kind of the base know-how for analysis. So linear regression is really good to know how to do, especially in Python. And as we can go back and look, it literally is super quick. I mean, it was all about 9-10 lines of code that made it so that we could do linear regression. So obviously these are just made up numbers, but if you did have more numbers, you could take this a step further and kind of do multivariable regression. And as well, if you want to, you could do like polynomial or logistic regression. I just like to stick with linear regression when I just have 2 variables. Makes it a lot simpler. And when you have a lot of data, makes it a lot simpler as well. So that's it for this video, guys. Thanks for watching. If you haven't already, be sure to hit the like button, and as well, be sure to subscribe to the channel. Come out with a lot of cool machine learning, tech, data science type stuff. That is it for this video, and I will see you in the next one.